explain the coding for task 1. At the beginning, we define the pins for the red, green and yellow LEDs using define. I use define instead of int because pin numbers never change. With define, the compiler simply replace the name with the number, so it doesn't use any extra memory, while using int would unnecessarily store it in RAM. Next, we create 3 arrays. The running array stores the step-by-step sequence of the LEDs. The first row has all LEDs off, the second row turns only the red LED on, the third row turns only the green LED on, the fourth row turns only the yellow LED on, and the last row switch all LEDs off again. This creates the effect of the light moving from red to green to yellow. The blinking array is simple. Its first row has all LEDs off and the second row has all LEDs on together. By alternating between these 2 rows, the 3 LEDs blink in unison. Finally, the pins array keeps track of which pin each LED is connected to. In the setup function, we set all LED pins as output so the Arduino can control them. Inside the loop, we first run the running sequence. Here, the outer index key repeats the entire running sequence 2 times. Within that, the index I moves through the 5 rows of the running array, while the index J goes across the 3 LEDs to update their states as either low or high. After updating all LEDs in a row, the program pauses with a 1 second delay before moving to the next row. When the 5 rows finish, the program waits another half a second before continuing. After this, the blinking sequence begins. In this part, the index A repeats the blinking cycle twice, while the index B switches between the 2 rows of the blinking arrays. For each row, the index C updates the 3 LEDs and then the program pauses for half a second to hold that state. Once both rows finish, there is another half second delay before the whole loop starts again from the beginning. Hi guys, welcome back to our channel. Today I'm going to do task 1 on Arduino Nano. So we have green LED, red LED, female wires to connect the LED to the Arduino board. Signal, signal, ground, connect to ground, connect the ground pin to the and the signal pin to the signal of the TV to the default pin. Signal, signal. Now we're going to test our coding.
In designing this program, our main goal was to keep the code efficient, structured, and easy to modify. Instead of writing long, repetitive lines for each LED, we used arrays to store the LED patterns. For example, we created the running array and the blinking array, which separates the sequence patterns that the LED will take throughout the function. This allows us to manage the running and blinking sequences in a structured manner without repeating multiple digital write commands. We also included a pins array, so if the hardware wiring ever changes, we only need to update the pin numbers once instead of editing the entire program. Now, to actually run the patterns, we used nested loops. This decision makes the program much cleaner because the loops automatically repeat the sequences as many times as needed. Without loops, we would have to write out every single LED change manually, which would make the code long, messy, and harder to modify. If we ever want to add more LEDs or adjust the timing, we can easily do so by changing the arrays rather than rewriting the whole program.
Hi guys, so today I will be going to show you how to do the practical for task 2. So just connect the pin wire to the ground and segment pin, and then connect it with the D2. So the ground black, ground zero. And then push button.